Okay, so today we're going to move on to the next part, which is distance between 2 points as well as middle point between 2 points. Let's have a look. You've got this handout in front of you, but let's just watch the board for now. I'll make it really big first. Okay, we want to find distance between 2 points. Got 1 point here, 1, 3, 1, 3. Another point here, 4, 7, 4, 7. Yep. So we want to find the distance between these 2 points if I join them. So I'm going to join them now. Yep. And in order to do that, I put that into a right angle triangle. Yeah? So let's do that. If I put it into a right angle triangle, you guys okay with that concept? Now, here's 1, here's 4. What's the horizontal distance? What is the horizontal distance? It's 3, right? 4 minus 1. Easy, right?
Yeah.
Good. Can somebody tell me what's the vertical distance? 4, very good. 3 here, 7 here. Just like yesterday we said y2 minus y1, same thing. Can we link that concept yesterday?
Yeah.
We said x2 minus x1, y2 minus y1. That part was exactly the same like yesterday. So we get 4. Yeah? Now, does that trigger any of the connection that we've done before? If it is a right angle triangle, it's 3 here, 4 here, what is my hypotenuse? What is my hypotenuse? That should take 1 second. 3, 4.
3 squared plus 5.
What is it? 5, exactly. Quite a few weeks ago, I wrote on that part of the board, I said 3, 4, 5, 6, 8, 10, 5, 12, 13. Those numbers pretty much should stick to memory. Is that okay? Or is it 3, 4, hypotenuse must be 5. 6, 8, hypotenuse just has to be 10. 5, 12 has to be 13. So those numbers, pretty much like a timetable. Just need to remember those things, right? Anyway, back to today. I got 1 point, I got another point. By using the Pythagoras theorem, we found out the distance between those 2 points is 5. If you understand that, let's go into, people understand so far?
Yeah.
Okay, if you understand that part, let's go into a little bit more detail. We're going to develop the formula, right? Let's have a look here. So, if I'm just going to draw x, y, if I'm going to draw any random points on the line. So, A, B. In other words, I want to find the distance AB, right? I call A is x1, y1, just like yesterday. B, I call it x2, y2. So far, so good?
Yeah.
And again, just like what I did here, I'm going to put that into a right angle triangle. Yeah? So let's draw that. I'm going to put A, B in a right angle triangle. I call that O. All good?
Yeah.
Now let's talk these two together. How do I find the distance of AO? Just like here. How do I find this part?
x2 minus x1.
Keep going.
x2 minus
x2 minus x1, fantastic. x2 minus x1, very, very good. How do I find the vertical distance of BO? y2 minus y1, well done guys. y2 minus y1, very good. Okay, back to Pythagoras theory again. It is a right angle triangle. I know 2 sides. How do I find the hypotenuse? A squared plus B squared equals A squared, right? Which you guys did in year 8. So it's exactly the same thing, just in a different context. So now I want to find AB. Yes?
Yeah.
So AB is gonna be square root of y2 minus y1 square plus x2 minus x1 square. Is that okay?
Yeah.
Do we understand that?
Yeah.
If you understand that, that's it, pretty much it for the first part of distance. Later on, we'll do middle point. Now, again, there are quite a few formulas to remember. In this chapter. This is one of them, and it's an important one. It's called the distance formula. Can I ask you to write down in your book now? This is called the distance formula. Now, in mathematics, we keep saying that there are so many formulas to remember, right? But I do not want us to remember it, because if we try to remember it by heart, we'll forget it, right? But if you just visualize the picture, what's going on, there's nothing to remember. Horizontal x2 minus x1, vertical y2 minus y1, then a squared plus b squared. Then after that, there's nothing to remember. Do we agree?
Yeah.
Just Pythagoras theory, but make sure you put the square root. But ultimately, that's what you do, is you are doing this. You are doing this thing here. 3 squared plus 4 squared. That's ultimately what we do. In terms of formula, that's the formula. The formula is useful when the number is not so nice or small. Yeah? But here the number is very nice and small. That's why we can figure out quickly it's 5. All good?
Yeah.
Let's go and have a look at a few more examples. This one here. Minus 3, 2. Minus 3, sorry, I typed in the wrong thing, I think. Minus 3 is 3, should be, I typed in the wrong thing. Sorry about that. Minus 3 is 3. And 2, negative 9. Now this time you can see the number is not so nice, not so small, excuse me, with negative as well. Yeah? So this 3, 4, 5, that sort of relationship may not work. So I have to put the internal right angle triangle and using the distance formula. So let's just try the distance formula straight away. So D represents the distance. Again, as we said yesterday, because we are new to this topic, we are beginners, it's good practice to label the points. So x1, y1, x2, y2. This point I found is, even I've done this for many times, right? I still found it useful. So when I substitute points, I don't put any random points or any round numbers. It just reminds you which point to substitute into. Okay? All right, what's y2?
9, negative 9.
Negative 9. Minus, what's y1? 3 squared. What's x2?
2.
2,
2. Minus, what's x1?
negative 9,
What's x1?
negative 3.
Is it plus 3?
It's just 2.
Okay,
Okay? Now, I just said yesterday, we want to see the substitution process. We want to see that. We want to see that in assessment task. Okay? Minus 9 minus 3 is? Minus 9 minus 3 is? Minus 12, right? Minus 12 squared is 144. 2 minus minus 3 is? 5 squared?
25.
25. That'll give you 169. That'll give you 13. Okay? All good? Have we get a genuine understanding of this sort of context?
Yes.
Okay. I'm not going to do another one, but that's we'll practice later. Okay. Now let's move on to the second part of today. We are still in 4H. We are going to do the second part of today is middle point. Let's write down the title.
10.
So essentially what we do in this session is distance as well as middle point. Alrighty, let's have a look. When we just say this phrase, middle point, what does it mean?
The origin.
What does it mean? What does the word middle mean?
Point in the middle.
Point in the middle. If I got a point here, I got a point here, how do I find my middle point?
You're the middle.
I got two two things, how do you find the point in the middle? Half it, exactly, right? Average. How do you find average?
Add everything by
Divided by what? How do you find average? Plus number together divided by 2. Right? That's exactly what we do this here. Let's have a look. I got 1 point. I got another point. I want to find the middle point. As we said, as the name suggests, it is just average. However, in order to do that, I must separate the x and y. I can't mix them, right? So let's call that is x1, y1. C is x2, y2. Now, the middle point of the x coordinate is gonna be x1 plus x2 and half it. The middle point of the y coordinate is y1 plus y2, half it. Then you're done. Nothing magical, right? All I'm doing is middle point, exactly halfway point. Yeah. So what's x1? Guys, come on, tell me what's x1.
1.
What's x2?
3.
What's y1?
1.
What's x2?
4.
Make sense? Always have a quick check when you finish to see if your answer makes sense. 2, 2.5. 1, 2, 2 here, 2, 3, 2.5. So it's correct. It's really, really important to just pause it for a second to say if my number makes sense. If you get a number that is ridiculous, then you know something has gone wrong. Again, if you understand that, that's it. That is it for the new content. I'm going to do a few more examples. Will not have the noise? Okay. Exactly same thing. Let's try another one. I'm going to do a little bit more complicated. How about you guys give it a go? Find the middle point. Give it a go. I want to find the middle point between A and B.
It's not the same. So
It's the same.
Oh, same thing, is it?
Yeah.
So sorry. How about we try? Okay, try negative case. I didn't mean negative number. I mean negative gradient. Let's give it a go. Anybody finish? All together, like seriously, all together should take 1 minute. All you do is plus divided by 2. And you really, really, really shouldn't use calculator. It's 3 plus 5. What is it? Come on, 3 plus 5 divided by 2.
4.
Why do we need the calculator for? 4 plus 2 divided by 2. 30 seconds. You agree? Right? That's how much time it should take you in an exam. Because these are, if I talk about A, B, C, D, these are like D questions, just must know. Okay? Like we haven't even done any of the harder stuff here. So it's 3 plus 5 divided by 2. 4 plus 2 divided by 2. You guys can finish the rest. All good?
Yeah.
Move on. By the way, one of the exam strategy I would like to give for future reference is spend minimum time on the like super easy ones. This is super easy ones. Like spend more time on the harder ones, so you're not wasting time. Yeah. Okay. This one. a little bit harder. I've got a point A. I've got a point D. This time the middle point has been given. I know the middle point, but I want to find out what is the other point. Where is the other point that makes my middle point 3, 2? At the moment, I don't know what the point of D is, right? I got no idea. I just call it x2, y2. Do you guys agree? Is it okay? I don't know where it's located at the moment, but I just call x2, y2. Using the middle point formula, I can find it out. I call this one x1, y1. All good? Okay. Based on our discussion of middle point formula, we said x1 plus x2 divided by 2 give me the middle point. Is that okay? Now you can see there's quite enough numbers flowing around the question, right? So make sure you are once again substitute the correct number into the correct formula. x1 plus x2, I half it, I get the middle point of x. I hope I make it clear. Is that okay? All good? y1 plus y2, I half it, I get that number there. I hope I made sense. Yep. Then this looks like simultaneous equation. Is not simultaneous equation because I can solve it for x, I can solve it for y. Good? So 2 plus x2 equals 6, x2 equals 4. Y plus y2 equals 4, y2 equals 3. So your answer is 4, 3 for D. Any questions? This one is a little bit harder, just only a little bit harder than the one we did 2 minutes ago. The one we did 2 minutes ago required no thinking. All you have to do is put the formula in. This one requires a little bit of thinking. Question?
So there's kind of a pattern because the A and B is like 2, 1, and then 3, 2. So it's going up by 1. So the next one would be 4, 3 because it just goes up by 1 each x and y.
Good. We can link in with that gradient as well. Can you guys try? Let me just see.
Doesn't matter which one's x1, which one's x2.
Oh, I normally call from left to right.
Does it matter though?
Which one you mean? Like?
Look, which one you label x2 or x1 as? So if you were to do it the opposite way, would it be the same answer?
Let's try. Yeah? Shall we try? I'm just going to, for the space, I'm going to put it here, yeah? Did you guys mean this one is x2, y2?
Yeah.
So let's try. Then you will see, yeah? So 2, 1, 3, 2. This one is x1, y1. Is that what you mean? Yeah. x2, y2. Try. You'll see. I can't tell you the answer now, but try. You'll see. In 2 minutes, you will know the answer.
I think you would just guess.
It does not matter at all. Try. You will see.
Because you're just using that as like a...
Yeah. The x1, x2 is just a symbol. You can do x3, x4. Just a symbol.
So use the same answer.
Try, you will see what I mean. Once you try, you believe in yourself, and that builds your confidence.